Here are the answers to number 7 and 8 on the momentum review paper. Number 7, two students on roller skates stand face to face, then push each other away. One student has a mass of 90 kilograms, the other has a mass of 60 kilograms. We're going to find the ratio of their velocities just after their hands lose contact. We're going to find out which one has the greater speed. Well, initially they have no speed because they're just standing there. So this whole left side of this equation is going to be 0. Meaning that the momentum after for the first person equals the momentum after for the second person, because the momentum has to be conserved. So if it started with 0, it has to end with 0. So they have to be equal, just in the opposite direction. So you have m1 v1 prime equaling m2 v2 prime. Now we're trying to find the ratio of their speeds. So if I were to divide mass 2 over to the left, I have m1 over m2. And I divide v1 prime over to the right, I'd have v2 prime over v1 prime. When I plug in my numbers for the mass, I know that the first mass 1, is 90 kilograms, mass 2 is 60 kilograms, which gives me a ratio of 1.5. So velocity 2, the speed of the smaller person, the 60 kilogram person is the second person, is going to be 1.5 times bigger than the speed of the larger person, the 90 kilogram person. Since the ratio of the masses is 1.5, the ratio of the velocities is going to be the same. It's just going to be in the opposite way. So the smaller person is going to move 1.5 times faster than the heavier person after they push off. Number 8, a .005 kilogram bullet is fired with a velocity of 100 meters per second toward a wall. So that's the initial speed of the bullet. Part A, what is the change in momentum of the bullet if it gets stuck in the wall? So we're looking for delta P, the change in momentum, and that's just equal to the final momentum minus the initial momentum. Well, the final momentum is 0 because it's stuck in a wall. It's just nothing. It's not moving at all. So the initial momentum is 0.005 kilograms times 100. So it loses all of its momentum. So it started out with 0.5 kilogram meters per second of momentum and went to 0. So it lost that 0.5 kilogram meters per second. So its change was negative 0.5 because that's how much it lost, because it went to nothing. For part B, what is the change in momentum of the bullet if the bullet ricochets in the opposite direction with a speed of 99 meters per second, almost the same speed it had originally? Now remember, that speed, since it's going in the opposite direction, is going to be negative. If we're saying that the 100 is positive, the opposite direction has to be negative. So the v after the ricochet is negative 99 meters per second. Change in momentum is still the same equation, momentum after minus momentum before. The momentum after is its mass, 0.005 kilograms, times its speed after the ricochet, which is negative 99 meters per second, minus the initial momentum, which is mass, 0.005 kilograms, times 100 meters per second, the initial speed. And we get a change in momentum of 0.995 kilogram meters per second. And that would actually be a negative. Not sure why the negative's not there, but when you plug all this in, you're going to get a very negative number here, minus some more stuff, so that should be a negative 0.995 kilogram meters per second.